show you the results of the principal component analysis. And the Holder pasteurized samples marked in red fell in the negative region of this PC1, and maybe is due to the higher level of oleic acid. And the untreated samples fell in the positive region because it has higher levels or palmitic and also myristic acid. So the separation also was good according to this statistical data. So if we compare the fatty acid composition according to the delivery mode, let's say we also could separate the caesarean section and also the vaginal delivery. And in the case of the caesarean section, those fatty acid was higher, occurred higher, that has inflammatory properties, while the normal cases in the vaginal delivery has the anti-inflammatory properties. So those fatty acids occurred in higher amount. So some conclusion for this part. Of course, the changes in fatty acid composition after Holder pasteurization is concerning, but it is important to find a strategy to balance this backdraw to the good benefits to the biological quality. And it would be good to develop the protocol to standardize and increase the quality of the donor milk. Maybe the fatty acid supplementation is a part of the treatment plan that improves the nutrition and growth. And all these initiatives will help to guarantee all newborns who need donor milk to receive the best possible nutrition. So I would like to acknowledge all of my colleagues who contributed to this research, and also the RICU for the financial support, and of course for you for your kind attention. Thank you very much.
Good. Thank you very much, Livia, for this excellent presentation. Is there a question from the audience?
Thank you so much for your very important presentation. I would like to know if the diet intake affect the quality of breast milk. Thank you. The diet intake is affect
we have some data of the diets, but it was not very well collected to be used as a scientific evaluation. But next time we will also try to compare. So already we have some data for the different diet, because the healthy women consume more vegetables and fruits, and the plant and animal origin food is more balanced. But not all cases were this well written or well justified. So that's why we don't use this data for this.
Because several studies, scientific studies, have shown that the quality of breast milk did not change, but the quantity related to the diet intake. Do you confirm that? Okay, thank you.
Is there another question? So then I would like to thank you again for your presentation, and I have a little present here for you. Thank you very much. And with that, I'm asking Edith Nadashi to the stage. She's from the Medifood Hungarian Innovation Ltd, and she will talk about the role of proteins in clinical nutrition.
Itt a pointer lehet léptetni. Jó, szuper. És nyomkodjam a mikrofonomat?
Maradok itt, látom, hogy tűnik jobb. Szerintem alacsonyabbra kéne. Köszönöm szépen. So thank you very much for this kind invitation, and I'm sorry for this little technical issue, but on behalf of Medifood, I would like to talk about the role of proteins in clinical nutrition. Why are we here with this topic? Because Medifood is a mid-sized company, Hungarian-Swiss company, which is specialized in clinical nutrition. Here are my disclosures. Why is malnutrition such an important question? Because I think for the people who work in the same field as we do, it's very well known from the literature that malnutrition decreases the therapeutic efficacy of different drugs used in the malnourished patients to treat chronic conditions such as cancer, IBD, etc. It causes more frequent and more serious complications and adverse events in these patients. There are more and frequent and more serious complications postoperatively in the patients. There are more frequent and more serious postoperative infections, especially in surgery patients. All these complications lead to longer hospital stay and longer rehabilitation period. It increases the therapy-related costs, and last but not least, it also increases the mortality of malnourished patients compared to their well-nourished ones. So the importance of clinical nutrition is here because in malnourished patients, the logical step, the logical solution to improve the nutritional status would be to give them something to eat, because malnutrition is usually caused by the decreased food intake and also the chronic anti-inflammatory processes in the background of the diseases. So it's proven also from the literature that clinical nutrition decreases the therapy-induced weight loss in these patients. It improves the nutritional status. It improves the quality of the patient's life, which is very important because it has a direct connection to the compliance for clinical nutrition in these patients, decreases the rate of complications, the length and rate of hospital stays, and also decreases the rate of the hospital readmissions. Last but not least, why these clinical nutritional products are actually accepted by the authorities, the healthcare authorities, it's because they are proven to decrease the therapy and hospital-related costs of the patients. Well, it's a little bit of a food question that they may also be even applied in food intolerances, but this is not the main focus of the clinical nutritional products. One aspect of malnutrition is sarcopenia, which is the loss of muscle mass and muscle strength. This also happens naturally when people get older, but it has a very high frequency and a very high rate in patients suffering from different chronic diseases. So since it's a loss of muscle mass, the logical solution would be to give more protein to the patients. But it's not so simple. Due to the different metabolic processes in the patients going on, it does matter what kind of protein we give to the patient and what amount of protein we try to give to the patient. So what kind of protein? Nowadays, the proteins we use in clinical nutritional products are mainly the animal-derived proteins, mainly milk protein isolate, casein whey, or the combination of these. Egg protein would also be a kind of solution, but it's not very widely used yet in the clinical nutritional products. According to the food trends of the past decade or 2 decades, there are also plant-derived proteins on the market, for example, soy, pea, etc., especially in certain conditions, for example, liver disease, where the amino acid composition of the protein is very, very important for the patient. There are also some alternative protein sources coming up, which might also be applied in clinical nutritional products, and these proteins are the insect-derived proteins and the single-cell-derived proteins that come from fungi, algae, bacteria, and so on. Due to the shortness of the time, I would only touch upon the plant-derived proteins and the insect-derived proteins regarding clinical nutrition. So what do we know about plant proteins versus animal proteins from this aspect? If we investigate the amount of protein, the protein content of the different plant sources and the animal sources, from this point of view, plant proteins is actually not bad. They could be used without any concern in such products. However, if we investigate the question a little closer and we have a look at the percentage of essential amino acids in the total protein, we see that the essential amino acid content of the plant-derived proteins are lower than the animal-derived ones. The dashed line that you can see right there on the slide is actually the amino acid requirements specified for adults by the WHO, the FAO, and the UNU. So you can see that most of the plant sources are below this dashed line, though the animal-derived proteins are above this dashed line. So this is one aspect. If we go a little bit even closer to this question and have a look at the essential amino acids one by one, we actually see more or less the same picture, that with several exceptions for the essential amino acids investigated one by one, the plant-based proteins are also contain a lower amount than the animal-derived ones. And for patients who actually struggle to eat enough protein already, a source which is lower in essential amino acid amount is not an optimal one. The second question regarding plant-based proteins and animal-based proteins is the so-called biological values. I've put this biological value in quotation marks because there is a value called biological value, but these are not the ones, because that biological value is already not in use anymore. One value which is still kind of in use is the PDCAAS, which is the protein digestibility corrected amino acid score. This actually shows how well the protein can be used in the body. As you can see, the second part of the table, there are the plant proteins or plants, and on the first part of the table, there are the animal-derived ones. As you can see, the PDCAAS values are lower for the plants than from the animal ones. There were two problems with this PDCAAS value. One is that it did not investigate at the end of the terminal ileum of the digestibility and use of the protein. And second is that they decided to truncate the value at 1, meaning that once the value got to 1, they did not care whether the value was higher than 1 or it was just equal to 1. So after a certain time, they developed this so-called DIAAS value, which is the protein digestible indispensable amino acid score. This actually has already taken into consideration the digestibility and use of the proteins at the end of the terminal ileum. And you can actually see the PDCAAS values here and the DIAS values here for the same proteins. And you can see that first, the plant proteins have lower values. Second, within the animal proteins group, there are proteins which actually have values higher than 100, meaning that they provide even more essential amino acids than the requirement specified for adults by the WHO. And you can also see that there are some significant differences between the different values for certain sources. So just to make it easier understandable, how much protein should be consumed of each source to satisfy the essential amino acid requirement? So if we have a look at this table, we can see that the least amount should be consumed from whey protein for a certain amount of essential amino acids. From all the rest, the patient should consume more to get the same amount of essential amino acids. However, it's also visible from the table that for the other animal source proteins, the values are actually close to the whey protein value, while for plant-based proteins, the values are higher. So again, just a logical step. If the patient is already suffering from or struggling to get enough to eat, for example, if we take the oat, the patient should consume 2.5 times more protein to get the same amount of essential amino acids than from whey. So for this patient population, plant-based proteins are actually not the best option. However, also from the literature, there are some methods how this lower anabolic response to plant proteins could be overcome. And the traffic lights are actually indicate how these overcoming methods are acceptable for the clinical nutritional products. So it's not for general use. First is the fortification with essential amino acids. This is quite a logical solution, but the problem is that a lot of essential amino acids actually have a very bad taste. So in a clinical nutritional product where the compliance is a crucial question, bad taste is actually not really an option. Of course, there are some techniques to mask this taste, but it's easier to use something which already has an acceptable taste for the patient. Second option is the selective breeding of plants to improve amino acid profiles. That's very good, but it takes a long time. So for patients who actually need something now, this is not really an option. Third option would be to consume greater amounts of plant-based protein sources. This is very good, but for patients who cannot eat enough, this is absolutely not an option. Fourth option would be to ingest multiple protein sources to provide a more balanced amino acid profile. This could actually be a solution. However, there are some technical questions and also the question of taste. I don't know how many of you already tasted the product which have been, clinical nutritional product, which have been produced with pea protein. So actually, I just would not like to get into a question, but it's really not good. So for the moment, we should stick to animal proteins because there are also some questions regarding safety with plant-based proteins. The first question is actually a mix of efficacy and safety because it's the question of antinutrients. Plants contain different molecules which are regarded antinutrients, meaning that these molecules bind to proteins or vitamins or trace elements and minerals, and they actually decrease their availability or their absorption in the gut, which is not really good for patients suffering from getting enough to eat. There are some controversial data or let's say, still unproven data in the literature on the beneficial or harmful effects of different plant-based proteins in different cardiovascular diseases, in menopause and postmenopause, in osteoporosis, especially in bone mineral density. For example, the question of soy in postmenopausal women in osteoporosis, then breast cancer, diabetes, and even male reproductive hormones. The genetically modified organism is a kind of other question, but this is also something which needs to be taken into consideration when we want to use plant-based proteins in clinical nutritional products, because animals are not yet genetically modified, but there are some plants which are already genetically modified. So the next big chunk of my presentation is regarding the insects and the insect products, insect-based proteins in the European Union. According to this publication from 2025, so it's a this year publication, these are these 8 different species which are actually allowed to be used or farmed for feed purposes in the European Union. To tell you the truth, I kind of know the English names, but I don't really have any idea what kind of species they are. I just know that there are grasshoppers and crickets and some kind of worms. If we go into the essential amino acids question, we can see that with some exceptions marked with the red arrows, for the essential amino acid content, the insect-derived proteins are actually good. So theoretically, they could be used on clinical nutritional products as well, because they do not require a lot larger amount to be consumed by the patients. However, there are still some questions regarding proteins, technological, ecological, economical, and last but not least, health-related questions. I'm only going to touch upon the health-related ones. There are some hazards which are not yet satisfactorily investigated regarding insect-based proteins as ingredients for clinical nutritional products. These insect products may contain some chemical hazardous molecules such as heavy metals, residues from veterinary drugs, toxins, halogenated organic compounds, and also agricultural waste residues from plant substrates mainly. However, these questions could all be solved as time goes on by applying very well-regulated methods in the farming of the insects. The other hazard is the microbiological one. A lot of people are actually concerned about the zoonosis, the diseases which can be transferred from animals to humans, but they do not seem the biggest piece of hazard regarding this question. It's rather the danger of the microflora, which may be infectious or hazardous for the patients, and this could derive from an inappropriate breeding, from the failure to comply with basic sanitary recommendations during the farming, and also the processing and the transport of the insects and insect-derived products. Actually, in a study where they investigated some insect-based products, they were able to isolate this kind of microorganisms from the insect-based products, like the Bacillus cereus, the coliform bacteria, some fungi, the Cryptococcus neoformans, which is a non-pathogen in especially immune-compromised patients. So as long as these microbiological hazards are not removed from these products, they cannot be used in clinical nutritional products. There is also the question of allergy. The allergy might be a primary one, so the patient may be directly allergenous to certain proteins or certain molecules from the insects. You can see a couple of examples here, but it's also coming up from the literature that there may be cross reactions between some insect-based products and crustaceans and house dust mites. Most probably, the root of this cross-reaction is because these different species are very closely related to each other. So just like as some plants may induce cross-reactions in allergenic people, this is the same case regarding the insect-based products as well. There is also the question of anti-nutrients. Here you can see a couple of examples. This question also needs to be satisfactorily solved before these kind of proteins can be used in any clinical nutritional products. Last but not least, there are still some barriers of acceptance, at least in the European countries, against this kind of products and proteins, because culturally, insect consumption is actually not part of the European diet. However, there was an acceptance study in Italy in 2020, and the results from this study are the following. The main barriers against acceptance is the appearance. So actually, if we can see that it's an insect, we are not really willing to consume it. Then there is the taste, which may be different from the very well-known proteins that we already have in our daily diet. The prejudice, because a lot of people think that anything coming from insects is unclean and it has health risks. The phobia, actually this is not just specific for the insect-based products. This is a phobia against everything which is new. But in this case, the Italian study found that this neophobia is actually rather due to the nature of the food, that it's coming from insects and not directly against the novelty of this food. Then there is the lack of information. And very interestingly, this does not mean the lack of information on nutritious facts, because a lot of people already heard from the media or from other sources that actually insects are very nutritious. This lack of information concerns the future challenge of the food security markets, meaning that as the population of Earth grows, there will be a higher and higher chance to provide enough food for all these populations. And that's why the insect-based products are also coming into focus, since they are a lot more easily farmed, they need less resources, and they still provide nutritious products for the people. The next barrier is the lack of experience just with anything else. If there is my neighbor who I trust and tells me that this is actually nice and tastes good, then I'm a lot more willing to try than if I have no such information. Because there are information of the public media, but a lot of people trust people who they know personally better than some information from publications or radio, television, internet, etc. Last but not least, at least in Europe, there is the lack of cuisine-related aspects. We just simply don't know how to handle this kind of food and how to prepare them. So according to the study, this barrier may be overcome by processing the insects beyond recognition. So people actually don't recognize what they eat. Then would be easier to have the people accept this kind of products in savory and salty foods. And this is actually a barrier for clinical nutrition as well, because most of the clinical nutritional products are tasting sweet, because these are the most accepted flavors by the patients. And last but not least, use of the protein-derived nutritional products. Plant proteins might be a viable option, but there are still some questions to clear up. And insect proteins may also be used in the future, but there are these questions that need to be satisfactorily answered before they can come into use. Thank you for your attention, and sorry for being a little too long.
Thank you very much for this interesting presentation. Unfortunately, due to time reasons, we are not allowed to take any questions anymore. So I already would like to ask the next speaker to the stage. This is Mercy Mukite Baraja from Mate University, and she is talking about the effect of surfactant-mediated solubility enhancements on the in vitro digestibility of plant protein isolates and concentrates.
Nincs. De nincs. Ja. Ja. Na most.
Jó, mindegy, kihúzom. Köszönöm szépen.
Van.
Yes. Thank you.
Okay. The stage is yours. This here.
Okay.
Hello, good afternoon, everyone. My name is Mercy from Department of Food Chemistry and Analytical Chemistry here at Mate. And my presentation today is a little bit touching on what the previous presenter was talking about plant proteins. And it's about using surfactants to improve the solubility of plant proteins and checking on the effect of this on the in vitro digestibility of these plant isolates and concentrates. So just like was mentioned before, plant proteins are a nice alternative in the protein market, especially since we are moving into alternative proteins, but they have very poor solubility compared to their animal counterparts. And this poor solubility affects their digestibility besides other functional properties. We experimented on the use of surfactants, in this case lecithin, quillia, and stevioside as our natural-based surfactants, and polysorbate 20 as a commercial surfactant to modify the protein-water interactions. Why protein and water? Because we are looking at beverage formulations that are being made with pH 7. And so mostly we were looking at the interactions with the water in this case. These interactions may increase the solubility of proteins, but there isn't much research on their effect on digestibility, since these surfactants will go on into the the stomach and the intestines to be digested, and we would like to see how are they affecting the digestion process. So we investigate whether this improved solubility is going to result in better digestibility. So question is, do solubility enhancers actually improve the digestibility in plant proteins? Our objective, one, was to evaluate the solubility with the mentioned proteins and surfactants. Then we used the InfoGest2 protocol to check for the in vitro digestibility. We looked at the SDS page profiles of the different protein fractions in the plant proteins, and we looked at the amino acid release patterns. We also determined whether the solubility improvement actually led to higher digestibility. In my methods, so first of all, I mixed the protein isolates, so concentrates. I was working with a minimum of 80% protein concentration in the powders. Mix it with surfactants on a magnetic stirrer for 1 hour, as shown there. And this suspension is then taken for solubility analysis. And the same suspension is also analyzed for in vitro digestibility using the InfoGest protocol as mentioned. We used 3 protein systems, fava, rice, and pea, 3 protein brands out of each of these 3. And we used 4 surfactants as mentioned, and 4 different concentrations of the 4 surfactants, and 3 replicates, of course, for each of the measurements. And we also had a control for each of the measurements. The results on the other section, I'm going to share them shortly. So one, when we look at the solubility of rice, for example, so these are 3 different brands of rice, we see a similarity in the patterns. For example, this is 0%. This is Remipro. It has the lowest solubility, less than 1%. We look at another brand, the solubility starts at 4%, and this one starts at 5%. But in each one of them, we see that there is an increase in solubility for each of the 4 different surfactants, lecithin, quillia, stevioside, and twin. Lecithin and stevioside have the highest effects in all of them. In this particular one, we tested up to 10% surfactant concentration. These are the ones we tested up to 0.5, and you can see there is still an increase even when you keep increasing the surfactant concentration. Quillia saponin has the lowest effect, while stevioside comes third with all of these. When you look at P, same pattern. P has a higher baseline solubility, 14 here, around 18 here, and around 13 point something here. So, but still, either way, we see that the surfactants do increase the solubility for each of the 3 different brands of P protein. Lecithin and twin still continue to dominate in terms of improvement. In the case of fava, these are 2 different types of fava proteins in the market, and we still see the same pattern with lecithin and twin. There's an increment, and in this one we also tested up to 10%, and we still see that it continues to improve the solubility. But the baseline solubility is also quite low compared to P in this case for NutriSmart, but this other type of fava has a higher baseline solubility. Moving on to the protein bands, so with SDS page, this is the whole suspension, this first one. We were able to identify, so this is an example of P. We were able to identify all the fractions of proteins present in P, just like in the literature. And we don't see any big differences between the concentration. So basically from the control, which has no surfactant added, compared to the ones where we added the surfactants, we don't see a very big difference. However, when we centrifuge and analyze the supernatant just to see what are the proteins that are solubilized, we do see some bands that are missing. So for example, in this section, which are the higher molecular weight proteins, like lipoxygenases are missing here. And also we can see some bands disappeared here compared to in the whole suspension. When you look at the amino acid release patterns, this is an example of the hydrophobic amino acids. Again, in the case of P, for example, we do see that there is a difference in how the two, in this case, lecithin and polysorbate act on the protein. So for example, in this case, we see that lecithin suppresses all the hydrophobic amino acids at high concentrations, whereas polysorbate 20 increases it at higher concentrations, at that is 0.5% for all the hydrophobic amino acids, showing that the two surfactants act in totally different ways, of course, with the same objective. In the case of polar uncharged, the same thing can be seen. Lecithin suppresses at very high concentrations, whereas polysorbate increases. And the same was also seen in basic amino acids, which are not shown here. However, when you look at the total amino acids, in this case, I used different protein and surfactant examples. So for example, with fava and lecithin, for the total amino acid release, we don't see a very big difference between the different concentrations, in this case, going up to 2%. There isn't statistically significant differences. When we look at rice and quilai, again, for total amino acid release patterns, there isn't a very big difference. However, in the case of rice with polysorbate, very high polysorbate concentration does reduce the amino acid release in the protein. I used PDCAS, as was explained in the previous presentation. We used PDCAS here, and I used an example of P protein to show the PDCAS results. And the baseline PDCAS is quite low for P proteins, starting from around 40 to 60, same to rice and fava. But in this case, where we have around 40-something% baseline, when we add surfactant, in this case lecithin and polysorbate, we do see a very big jump here. But the jump does not continue. So basically, after improving to a certain point, there is no significant difference, meaning we don't really need to keep on increasing the concentration of the surfactant to achieve a particular level of digestibility. The mechanism of improvement here, we postulated that it is the surfactants are modifying the protein structure, therefore increasing the enzyme accessibility. There's a difference between the low concentration, which reorganize and loosen the protein network, while at higher concentration, there's displacement of proteins, which expose the cleavage sites. In this case, we were looking at the SDS page during digestion. So this is before digestion. This is how we saw this before. This is how it looks like. During digestion, this is the supernatant, so the digestible fraction of the from the digestion, the in vitro digestion. Ignore this, but this is the enzyme. So these bands do not matter. But we see that there was a full digestion that happened, and we have very low molecular weight peptides here that can be seen in the digester. Whereas when we look at the indigestible fraction, which we call the pellets, minus this part, we can see some digestion did not happen. And in this case also, there's a bit of smearing here, meaning there was incomplete digestion of some of these protein bands. And you can see them here. So showing that, yeah, some digestion happened, but in some cases, but it was incomplete, and it ends up in the indigestible fraction. In conclusion, we do acknowledge that yes, solubility, surfactants improve the solubility and enzyme access, but higher solubility does not necessarily mean higher digestibility. And so we need to optimize the use of surfactants for improvement of solubility. And also for nutritional quality, the surfactants improved the nutritional quality across all the proteins and across all the surfactants. However, there is a need for optimal dosing and further in vivo validation for these measurements. And the processing as well, it does affect, as you can see, you could see from the different types of brands that there was a different baseline digestibility or baseline solubility. So processing effects also do affect the different proteins and how they will react to the surfactants, but they do not overly compromise the digestibility. Thank you so much for listening, and thank you to my supervisor, Professor Branco, and my colleagues, Judith, Dr. Sani Sheniko, Gabor, and Amira. Thank you so much.
Thank you, Mercy, for this very informative presentation. So now we have some time for questions from the audience.
I can ask a question, a quick one here. So you add the surfactants into your digestion, and do you think the surfactants will not affect the enzymes? Or did you test for that?
We do think that maybe they do, but that's why we had a control where we have a blank, the blank control where it's a protein-free and only has the enzyme, and we used it to remove the background in our measurements. Thank you.
Question? If not, thank you again. And now I would like to invite our next speakers from the Debrecen University. She is Valaha Alibrahim. So, and she will speak about the cruciferous food, a natural preservation meets therapy promises.
Okay, here's the point.
Can I use this one? Yeah? Okay, thank you so much. Okay, thank you. Hello everyone, my name is Wala Ibrahim, University of Debrecen, Nano-Food Lab. Today I will talk about allyl isothiocyanate as from cruciferous vegetables as a natural food preservative. First of all, allyl isothiocyanate as a bioactive compound extracted from cruciferous vegetables, such as mustard, horseradish, and wasabi. This compound is responsible for sharp taste of these vegetables. It has gained a significant attention due to its diverse biological properties, including anti-cancer, anti-inflammatory, antioxidant, and antibacterial. One of the key applications of this compound is used as natural alternative to synthetic additives. To obtain this compound, we use the best way by enzymatic conversion. First of all, syngerine. First of all, syngerine, which is a glucosinolate compound, present naturally in cruciferous vegetables. So when plant tissues are damaged by crushing or cutting, myrosinase enzyme is released and hydrolyzes syngerine to give allyl isothiocyanate, glucose, and sulfate in the presence of water. Why we should use allyl isothiocyanate in food industry? As we know, food industry needs natural options instead of chemical preservative. So we can use this compound because it's safe and eco-friendly, and also it has antimicrobial actions that leads to extend shelf life naturally, which makes it very useful for modern food. As I mentioned, this compound has antimicrobial activity because it can inhibit many foodborne pathogens. For example, Escherichia coli, Staphylococcus aureus, Salmonella, Listeria. Also, it can suppress molds and yeasts which are responsible for spoilage. What's interesting is that allele isothiocyanate works both in liquid and vapor phases, which gives it a unique advantages for diverse packaging applications. Allele isothiocyanate has mechanism of presentive depending on the type of bacteria. For example, in Escherichia coli, it can disrupt cell membrane integrity, causing leakage of essential ions and proteins from microbial cells. Also, in Staphylococcus aureus, it can react with sulfhydryl groups of critical microbial enzymes, preventing normal cellular functions. Also, it can inhibit ATP production and DNA synthesis, starving cells of energy needed for survival. Finally, its complete microbial cell death occurs within a few hours of exposure to effectiveness, isothiocyanate concentration, and it can act synergistically with other natural antimicrobials like essential oils and organic acids. Regarding to its benefits, it has using in different food applications from meat, dairy, seafood, and sauce. It also used in modified atmosphere packaging to prevent microbial growth, extend shelf life, as I mentioned before. So also it can improve the flavor and aroma profile. There are several studies confirm allele isothiocyanate effectiveness. For example, when we are fish cakes treated with allele isothiocyanate, that leads to extended shelf life over 30 days at 40 degrees Celsius without microbial spoilage. Sorry. Also, with cheddar cheese, when allele isothiocyanate treated with it, it can extended shelf life over 10 weeks, and hamburger meat showed significantly fewer spoilage bacteria. Regulation says allele isothiocyanate is safe if used within limits. For example, in Europe, 5 milligram per 1 kilogram, as I mentioned, in Europe, and 0.% in USA. It's officially classified as GRAS, meaning it's safe when used correctly in food. Despite its benefits, allele isothiocyanate faces some practical challenges. For example, volatile and unstable during processing, strong smell can change the product taste, limit water solubility, and high cost and regulation limit its use. Finally, requires controlled release or encapsulation. Finally, for the future research goal for allele isothiocyanate, we want to focus on enhancing stability, determining optimal doses, addressing toxicological concerns, developing scalable production methods, and achieving regulatory approval and expanding application. I want to ask my colleague from Carbon Nanodot lab and my supervisor Joseph Brokesh. And if you are interested to see our review, you can scan and read. Thank you for your attention.
It's a short summary or quick summary. Is it the preliminary work, or you work on this a bigger project within a bigger project?
Yes, this is the first step of our project, but we are prepared to prepare from allele isothiocyanate carbon nanodot to enhance stability and volatility and to find solution for these challenges.
Thank you. Are there any questions from the audience? If not, thank you again and congratulations. And we move to the next speaker. Györgyének is, and she will give us an overview of organic food consumer behavior in Hungary.
Ladies and gentlemen, it's a pleasure to welcome you today. I'd like to speak briefly about organic food consumer behavior in Hungary with a special focus, drivers, barriers, and incentives for purchasing. Firstly, let's look at what do we mean by organic. So it is a product produced, inspected, and certified in accordance with the legal requirements for organic farming. It is a sustainable farming and food production system that prohibits or limits the use of substances and technologies that are potentially hazardous to health or the environment, for example, a chemical pesticide or synthetic fertilizer or GMOs. Here you can see the current EU regulation. This figure shows the situation of organic production and market. By 2023, organic land has increased to 19.5 million hectares, and at the same time, the European market increased slightly, reaching 54.7 billion euros. The annual capital spending is 66 euros. According to the latest Hungarian data, more than 320,000 hectares or 6.4% is under organic cultivation. But until now, we had only estimates regarding the organic retail sales in Hungary. That's why it is a good news that we published a study on the retail sales of organic food between 2022 and 2024. Based on this, the total sales volume of organic products has grown by 36% in the studied period, reaching 38.7 billion Hungarian forints. But currently, the average annual per capita spending on organic food is not so much. It is around 10 euros. And organic baby food has the highest sales turnover, followed by organic vegetables and fruits. So consumer behavior of organic food was assessed in 2024 using online questionnaires. We collected 1,000 responses. The sample was representative in terms of settlement type and age. And after weighting, it was also representative of gender and education level. The data was analyzed using by SPSS statistical program. We used descriptive statistics, relationship analysis, and factor analysis as well. And we had the following research questions. What are the most popular organic product groups and sales channels according to the consumers' feedback? What types of consumer groups can it be identified based on their purchasing habits of organic food? Then what sparks or strengthens the interest in purchasing organic products by clusters? What are the main barriers to purchasing organic food in each cluster? What incentives encourage consumers to buy organic food? And last but not least, how much would people be willing to spend more for organic food? And let's see the results. This bar chart shows the frequency of buying organic food through e-sales channels. As we can see here, discounts are at the top of the list, followed by hypermarkets, supermarkets, then farmers markets, and direct sales from the producer, organic food stores and drugstores in the middle of the list, while organic boxes were not so popular. This bar chart illustrates the frequency of consumption for each organic product category. Nearly 45% of respondents purchase organic vegetables and fruits at least once a week, marked by green colors. Around 1/3 buy eggs and milk with the same regulatory, and close to 1/5 of the respondents consume organic dairy products, and processed vegetables and fruits and dry goods are in the middle of the list. But tea or alcoholic beverages are not so oftenly purchased products. We could identify 3 different clusters: considered, conscious, and skeptical. And here you can see the major characteristics of these clusters. So to summarize them, considered consumers are mostly urban, young adults from the Z generation, mainly women with moderate knowledge on organic food. They have secondary education level. They buy organic products weekly or monthly, often from discount stores, hypermarkets, or direct sales channels. And the second group, conscious consumers, are the most dedicated group. Primary women aged 30 to 44, but also the younger generation can be seen here as well. They purchase organic food the most oftenly. So they purchase these products from discounts, drugstores, hypermarkets, supermarkets, and they use organic boxes as well. They often live in the capital, and they have the highest knowledge on organic food. And the third group, the skeptical consumers, are mainly from the older generation. They less informed about organic food, and the regular purchasing intention are not so dominant here. And now, let's see the results. So this bar chart shows what sparks or strengthens interest in purchasing organic products by cluster. Across all clusters, the most influential factor is personal decision-making. And the second important factor was information and promotion received directly from the producer. And as we can see, direct information from the producer and personal contact with other consumers is especially important for conscious and considered consumer, while skeptical consumers rely less on these sources. But interestingly, conscious consumers are more responsive to professional articles and in-store promotions, reflecting their higher engagement and knowledge level. In contrast, media channels like television, radio, or newspaper are generally less effective across all clusters. And medical recommendation and in-store advice have the lowest impact overall. Here we can see the main barriers to buying organic food by clusters. High price is the most significant obstacle for skeptical and considered consumers. Limited supply and difficult access are also notable issues, particularly for conscious consumers. Barriers like inadequate promotion, low credibility, and little information are rated similarly across groups, showing a general lack of trust or awareness. Short shelf life is moderately relevant, while factors like taste, recognizability, and appearance are less influential overall. So lower prices, improved affordability, increased availability, and reliable communication could help increase organic purchases. Here you can see what incentives encourage consumers to buy organic food in each cluster. The availability of Hungarian organic products is the strongest motivator, especially among conscious and considered consumers. Price reduction was the strongest incentive in a skeptical consumer, and wider access also ranks high across the board. Freshness, increased supply, and offering organic food in schools are seen as important, particularly by conscious groups marked by green. Meanwhile, the availability of semi-finished or ready-to-eat organic products is rated slightly lower, especially by considered consumers. And this is our last result. So we found a significant positive correlation between how often a household buy organic food and how much more they are willing to pay for it compared to non-organic food. So, for example, it can be seen that those who buy organic food at least once a week, marked by different kind of green colors, so they are willing to pay a premium from 31 to 60%, or those who buy monthly are most willing to pay 10% premium. So as a conclusion, we can see that the most preferred product groups are fruits and vegetables. The most preferred sales channel was discount. And the strongest driver to purchase organic food was personal preference. The main barriers were high prices and limited supply. And the most important incentives were lower prices, reduction of consumer prices, and the demand for domestic organic products. So I propose to develop a well-designed targeted marketing strategy with a special focus of segmented marketing communication. And I think the public education is also a very important aspect. So thank you very much for your attention.
Thank you very much for this nice presentation. Maybe we have time for one short question. Please.
Thank you very much for your presentation. You said that we can encourage the purchase of organic products if the consumers receive direct information from the producer. That can be one of the main driver. What do you mean by that? Is it a direct marketing or labels, or what do you mean by promotion by the producer?
Mm-hmm. It's a wider range. So the labeling, the information in the product, and also the storytelling can be in this spectrum. So in this questionnaire, we didn't wanted to ask in a special form, but yes.
Thank you very much once again. And now I would like to invite Victoria Such, and she will speak about the gluten-free product and lifestyle.
Thank you so much. As the last presenter, I will try to provide a fitting conclusion to this excellent section and also to this really nice conference. My name is Victoria Such, and I'm a head expert at the Hungarian Chamber of Agriculture. And first of all, I would like to say a few words about my institution background and try to explain why we deal with topics such as this. So the Hungarian Chamber of Agriculture as a public body was founded in 2015, and it covers all members of the food chain. I mean, from farmers to the retailers. Currently, HCA has approximately 318,000 members from the whole food chain. And it develops cooperation with the members of the entire food chain, as well as with the government, social organizations, and consumers too. As the member of the Directorate of the food industry, our aim is to try to increasing the competitiveness of the Hungarian food industry enterprises through knowledge transfer, shaping the regulatory environment, supporting innovation efforts of the producers. Members can perform different ad hoc working groups in the chamber. In light of this, the working group of Free From Foods was formed in 2024, which set a dual goal as part of its market research work. The one is the detailed analysis of the range of the free foods, free products. And the other one is the analysis of the nutritional habits and product satisfaction of the consumers. So the working group chose gluten as the main character in the market research task. And if we really consider gluten as a main character of a movie, we can describe it having multiple characters. It can be the good guy, the soul of the bread, the main ingredient of the fresh, crispy, and wholly products. It can be the ugly one, the main enemy of the fashionable dieters, and also the bad one, a food ingredient that must be strictly avoided by those who are sensitive to gluten. Regardless of how we characterize it, all market research companies agree that the gluten-free food market will continue to grow in the upcoming years. So despite the fact that gluten-free products are niche products, they represent a really important market segment as they are currently the only known treatment of consumers having celiac disease. So It is therefore really important that the food industry meet their needs with the utmost care and quality. So for this purpose, in 2025, we conducted an online survey among more than 1,600 consumers in Hungary who follow a gluten-free diet to examine their eating habits and product satisfaction. We also conducted a self-survey in 9 online stores covering more than 2,200 products to obtain a detailed overview of the product range and their characteristics too. So looking at the results of the questionnaire survey, it can be said that more than half of the respondents follow a diet based on medical diagnosis, and 20% do it because hoping positive health effects, while 25% of them because there is someone in the family with celiac disease. The majority of the medical dieters learned of their condition after the typical symptoms appeared, while the rest of learned of it through other tests or reasons. A significant 3/4 of the respondents follow additional dietary restrictions besides the gluten-free diet. Most commonly mentioned was the lactose, milk, added sugar, and or carbohydrates. It is important to see and to note that these restrictions further narrow the range of foods that can be consumed by these consumers. So the food industry have really difficult product development task in this field. Adherence to the diet is most difficult when consumers eating out, and due to the price of the products, according to the answers. However, it is positive feedback that product labeling is viewed relatively positive, and and the consumer makes purchasing decisions based on thorough product knowledge and follow their diet with strict shelf discipline. Our further questions also confirm the trust in label information. Less than half of the dieters find gluten-free labeling sufficient, while more than 60% consciously browse the list of the ingredients and the food products. The crossed out grain symbol gives a sense of security for them. They agree that this symbol means that the product does not contain even traces of gluten. A significant part of our survey examined the satisfaction with the different product groups. The results showed that consumers tend to dissatisfied with the characteristics of the products currently available on the grocery store shelves, mainly with their price. We analyzed their selection, domestic selection, availability, sensory profile, and also the price as the characteristics. So in terms of selection, availability, and sensory properties, flour mixes, pasta, and meat products received relatively favorable feedback, while the convenience food and the ready-to-eat foods, the most negative feedback. The assessment of price, confirming the findings of the previous questions, proved unfavorable for all product categories. Results of the shelf survey confirm the consumer opinion that the range of sweets, cookies, salty snacks, pastas, flour and flour mixes is the widest, while the range of convenience food and food suitable for the busy lifestyle is more limited. Analyzing the results by store type, because I do not want to give the name of these online stores, it can be said that the ratio of the Hungarian products was the highest in the wholesale, following by the online grocery shop and the store with a mixed portfolio, it's druggery and the food online shop, and the lowest in the drugstores. However, the number of the gluten-free products was the highest in the drugstores and in the online store examined, and in the online store, which was due to the terminology of the classification they used. In addition to the labeled products, these store also classified foods that are naturally gluten-free into this category. So that's why it has a high number of gluten-free products in the online store. Looking at the diversity of the main ingredient, the primary ingredient, it can be said that the drugstores and the online stores has the most colorful product range, while the supermarkets and hypermarkets and also the wholesale are much more monotonous, we can say. What can we learn from this study? The quality of eating out should be improved in order to enhance the safety and well-being of these dieters. Product development should focus on multiple sensitivity and convenience foods, and adequate information is needed on the use of kitchens at home to avoid unnecessary dietary restrictions of the family in the family. And by combining the quality, the accessibility, and awareness, we can create a food environment that truly supports the health and well-being of celiac and dieter consumers. Our free downloadable publication entitled Gluten-Free Foods will soon be available on the Hungarian Chamber of Agriculture's website. And in addition to the details of these results, these surveys, it will contain further useful, relevant information about gluten-free products and the market too. This is the end of my presentation, so if you have any question, please feel free to contact me, and thank you for your kind attention.
Thank you very much, Victoria, for this excellent overview of this very hot topic nowadays. Any question from the audience? Do you have data how many people go on this gluten-free diet without requested? Because we have heard that it's the increasing number because it's a fashion to follow this, and it maybe is very harmful to their health.
It's difficult to answer because these consumers sometimes start it, sometimes finish it. So it's a fashionable diet, we can say. But the medically diagnosed celiac people in Hungary, it's around 1%, and according to the literature, it's around 10 and 15% who fashionably do this diet. So much more higher, yeah.
Thank you. Question? If not, I would like to thank once again. And now we come to the end of this scientific session. I would like to thank my co-chair, Rachel, to co-chair this session contribution, and all the speakers in the second part of this afternoon. And don't go far away because we soon started the closing ceremony, but we have to wait the parallel session to finish. So please take a small short break and come back again as it is indicated on the program. So thank you very much for your attention. I would like to ask you to come back, take the seat, because we would like to start with the closing ceremony, maybe which is the most important part of the conferences. Dear ladies and gentlemen, may I ask you to try to finish the coffee break and come back to the stage.
Néhány szót mondok.
At the last part of the conference, maybe the most important part, there will be some awards. But before we hand it over this, I hand over the microphone Professor József Felföldi to take some closing remarks.
Thank you, Livia. So as she mentioned, we have arrived at the closing event of the conference.
When we started to organize the event, our aim was to bring together scientists, engineers, and students from the universities as from the food and from the food industry to present ongoing research activities and hence to foster research relations between the universities and the industry. I believe that from that point of view, the conference was successful. The 252 registered participants of the events from 25 countries presented 65 oral presentations and 78 posters in 10 scientific sessions. And what is even perhaps more important, we witnessed meetings of old friends and new acquaintances, maybe friendships. On behalf of the host institution, I would like to thank our helpers and supporters. During the organization and the implementation, you met all the colleagues of the Institute. Many enterprises also supported the event, for example, with interesting and useful exhibitions in the hall. And thanks to our main sponsor for the financial support of the National RTI Fund. But the biggest thanks go to you, who brought us the latest and most interesting results, even from the most remote places in the world. I believe that with your contribution, the world's leading food science knowledge has been concentrated in Budapest over the past 2 days. I hope you will return home with similar experience when we will close the conference. But before the closing, I give the floor to Livia from some special thanks.
Thank you very much. I also would like to thank all the participants, exhibitors, organizers. And now I also would like to thank some people who contributed to the conference as a chair or co-chair, but not deliver lecture and missed to get some presents. So that's why I would like to list some name and please ask those who hear their name, and we would like to present some small Hungarian presents. Saumeidam, Muying Du. Please come here. Gabriella Kisko, Ágnes Keresztesi, Zsuzsanna Mednyánszki, and Zita Seres. Please. I will announce 3 important names who will awarded the Best Poster Prize, the equal quality, no ranking. So please come to the stage to get this nice diploma and also some small presents supported by the Sartorius company. Tanver Ahmed. Gabriela Surovec and Ningyil Liang. Sorry for my, maybe everybody can see their name correctly. Thank you. So we arrived really the very end of this conference. I hope you enjoyed this meeting and will come again here in Budapest or visit at our university. Everybody welcome anytime. So we close the conference, but don't go far away because we have a very nice tasty lunch, high quality, very tasty, and a little bit too much, but maybe we earn after these 2 days hard work, we need energy. So please enjoy your meal. And I have a very important announcement. Those who are invited to take part at the organ concert in the St. Stephen Basilica, we meet 20 sharp. So 20 in front of the Basilica. So the open door, because we have to enter as a group. So see you, some of you in the evening, and all the others enjoy Budapest and have a safety home if somebody go directly to home. So see you next time. Bye. van? Ez jó? Excuse me, maybe I am a little bit tired. I was wrong to announce the meeting time. So 7:20 in front of the Basilica. Excuse me, so 7:20. Okay? In front of the Basilica. Okay.